Okay, guys, let's take a look at these. Like I said, depending upon how I did all of them, but now, ladies and gentlemen, for number 1 and number 3, if you wrote them as x plus 4 times x plus 4, that's fine, but remember it's equivalent to x plus 4 to the second power. Some of you are using just do it, which is absolutely fine. So again, if the leading coefficient in front of x squared is 1, you're looking for numbers that multiply together that give you 16, but when you add together give you 8. So the pair of factors of 16 when add together give you 8 would be your plus 4 and plus 4, because 4 times 4 is 16, and then 4 plus 4 is 8. So then you can factor it as x plus 4 times x plus 4. I believe that's how some of you learned how to do this. I use slide and divide, but again, I don't care what method you're using to factor, but you have to be able to factor these. So if you're not sure, I'll be more than happy to show you slide and divide. It's just another way of factoring besides using this X method. Does this X method look familiar to a lot of you? Yeah, okay. So any questions on 1 and 3? Now, with number 4, when you set up your factoring, guys, don't let that x to the 4th throw you. Remember, all you're going to do is take the square root of x to the 4th, which is why instead of writing an x and an x, we're writing an x squared, because that's the square root of x to the 4th. But don't forget, ladies and gentlemen, especially when you're factoring with x to the 4ths, one of these sets of parentheses may be able to be factored further. X squared minus 9 is another difference of squares, so you need to make sure you factor it further. I know that's number 4. I didn't ask you to do that one, but just beware of that. All right. Are there any other questions on, I don't know what happened to number 7, but any questions on 5, 11, and 13? Yes, Katie?
Can you go over 9?
Number 9. So after I factor out the 2, so you still always look for the GCF. So what you want to do when the leading coefficient is not equal to 1, what you're going to do is you're going to multiply your leading coefficient by your constant. So I'm going to multiply 2 times 3, which is 6. And I want to figure out the factors of 6 that add together give you negative 7. So the numbers multiplied together to give you a positive 6, when you add together give you negative 7, would be a negative 6 and a negative 1. So now what you want to do is you want to rewrite your trinomial, again, bringing your 2x squared back in, so 2x squared minus 6x minus x, and then it's going to be your plus 3, I think. Did I set this up right, those of you that use this method? I use slide and divide, so I think this is the way it works. Factor out, so now remember you're going to do grouping. You factor out your GCF out of your first set of parentheses, so I can factor out a 2x. That's going to leave me with an x minus 3. The GCF I can factor out of the second set is a negative 1. Remember, these parentheses have to be identical. So now what I can do is I can do GCF factoring again, pulling out that x minus 3. So my answer is going to be x minus 3 times 2x minus 1. And don't forget that original 2 that you factored out in the beginning. Okay. So any questions on that one? So anytime you have a number in front of x squared, you have to rewrite, again, multiply the leading coefficient of the constant, which gives me my 6. You still want to look to see what number added together is going to give you that negative 7. And then you rewrite it as 4 terms, using these 2 factors that you found. Okay. There's a lot, ladies and gentlemen, there's a lot of different ways out there that you may have learned how to factor trinomials like this. So now let's take a look down here at the bottom. Still have trinomials. Sine squared minus sine theta minus 30. By the way, what is the coefficient in front of sine theta right here? The coefficient is a what?
Negative 1.
It's a 1. So what you're doing, remember, is you're looking for factors of negative 30 when add together give you negative 1. So what numbers multiplied together give you negative 30, but when you add them together will give you a negative 1? It's going to have to be a 5 and a negative 6. So the way I can factor this would be a sine theta minus 6, sine theta plus 5. So now look at number 15. The leading coefficient is still a 1. So we want to find the factors of negative 9 that add together give us a negative 8. So the magical pair is going to have to be a negative 9 and a positive 1. So this will factor into cotangent theta minus 9 times cotangent theta plus 1. If it makes you feel better, if looking at that cotangent and looking at the sine like you had in number 14, you can just rewrite it treating the sines and the cotangents as an x. Remember, this expression here is going to be factored in exactly the same way as x squared minus 8x minus 9. So if it makes you feel comfortable, just let x be equal to the cotangent theta. Factor it your normal way, and then substitute cotangents back in for x's. So if you're kind of getting tripped up because you've got that trig function in there, rewrite it in terms of x, and then bring the cotangent back in. Just like this one, you can do this one as 15x squared minus 2x minus 1. So if you're not sure that cosine squared is throwing you off, rewrite it in terms of x. So again, the leading coefficient is not equal to 1, so you have to multiply 15 times negative 1, which gives you a negative 15. So you're looking for factors of negative 15 that add together give you negative 2. So what's the magical combination going to be? What numbers multiplied together give you negative 15 but add together give you negative 2?
5, 3,
Which one's negative? Negative 5. So negative 5 and positive 3. So that I can rewrite this trinomial as I can rewrite this as a 15x squared minus 5x plus 3x minus 1. And what you're doing is you're factoring by grouping. Group together the first two terms, group together the last two terms. What can I factor out of the first set of parentheses? I can factor out a what? 5x. And that's going to leave me with a 3x minus 1. Notice I already have a 3x minus 1 in the second set of parentheses. So just imagine factoring out a positive 1. So then my final answer is going to be 5x plus 1 times 3x minus 1. Okay? So any questions on that one? What you've been doing when the leading coefficient is not equal to 1, you've actually been doing factoring by grouping. Remember, grouping is very obvious to recognize because you're going to have 4 terms. So anytime you see 4 terms in the original problem, you're going to be factoring by grouping. So the way grouping works is you group together the first 2 terms, you group together the last 2 terms. You want to factor your GCF. What's the GCF that's going to come out of this first set of parentheses? What's going to come out here? X squared. So I'm left with an x plus 2. What's the GCF that's going to come out of the second set of parentheses? I can pull out a what? 4. Remember, for grouping to work, those 2 parentheses have to be identical, which they are. So I can pull out my x plus 2, and I have an x squared plus 4. So that's how you do factoring by grouping. Okay? Remember, these 2 parentheses after you do GCFs have to be identical. So you guys go ahead and try problem number 2 through 6 for me. Go ahead and try 2 through 6 for me with grouping.